The pricing method of set fee per outlet plus a set fee per service is commonly used in the construction industry for pricing electrical work. Typically, when contractors quote a price this way, the equipment costs are not included in the flat rate. The flat rate generally only covers the labor costs for rough-in, meaning the installation of electrical wires and devices, and trim-out, meaning the installation of covers and faceplates. The varying rates for different types of outlets and services reflect the different labor requirements and material costs associated with each type. For example, a switch may require less labor to install than a general receptacle, so it is often quoted at a lower rate. There are advantages and disadvantages to this type of pricing. Firstly, it simplifies quoting and pricing. Secondly, it allows contractors to maintain a consistent profit margin. Thirdly, it can be competitive when the contractor has a high volume of similar work. Disadvantages include, firstly, that it may not account for the actual equipment costs, which can vary. Secondly, it can be less transparent for customers, as they may not understand what is included in the price. Thirdly, it may not be suitable for projects with unique or complex requirements. The traditional pricing method, which includes time, equipment, permits, and profit, provides a more detailed and accurate estimate of the total cost of the project. However, it can be more time-consuming and requires more detailed planning. This pricing method can be a reasonable approach for straightforward electrical work where the equipment costs are relatively consistent. However, it is important to clearly communicate what is included in the flat rate to avoid any misunderstandings. Ultimately, the best pricing method for any project should be chosen based on the specific circumstances and the contractor's expertise. Let's delve deeper into understanding electrical installations and pricing, focusing on the components, labor, and codes that influence costs and safety. When discussing electrical installations, it's essential to understand the components involved. These include, but aren't limited to, wiring, conduits, boxes, devices such as switches and receptacles, lighting fixtures, and panel boards. Each component has a specific purpose and associated cost. Wiring is the backbone of any electrical system, and its cost depends on factors such as gauge, material, and insulation type. For residential wiring, non-metallic sheath cable, commonly known as Romex, is frequently used. Its cost is relatively low, but its application is limited to dry locations. For commercial or industrial applications, conduit wiring is common. Conduit protects the wiring from physical damage and moisture. Types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each has varying costs and applications. The electrical boxes house the wiring connections and provide a mounting point for devices. They come in different sizes and materials, such as plastic and metal. The choice depends on the application and local codes. Devices like switches and receptacles also vary in cost, depending on their quality, features, and amperage rating. For example, a standard 15-amp receptacle is less expensive than a 20-amp receptacle or a ground fault circuit interrupter receptacle. Lighting fixtures can range from simple incandescent fixtures to complex LED systems. The cost of lighting fixtures varies widely depending on the style, efficiency, and light output. Panel boards distribute electricity throughout the building. They contain circuit breakers that protect the wiring from overloads and short circuits. The size and capacity of the panel board depend on the electrical load of the building. Now let's consider the labor involved in electrical installations. Labor costs can vary widely depending on the location, experience of the electrician, and complexity of the job. The labor for rough-in includes installing the wiring, conduits, and boxes. This is typically the most labor-intensive part of the job. The labor for trim-out includes installing the devices, fixtures, and covers. This is typically less labor-intensive than rough-in. The labor for connecting the panel board and making the final connections is also a factor. Electricians may charge by the hour, by the day, or by the job. The hourly rate for an electrician can range from $50 to $150 or more, depending on the location and experience. The cost of electrical permits is a significant factor in electrical installations. Electrical permits are required by local codes to ensure that the work is done safely and up to code. The cost of an electrical permit varies depending on the scope of the work and the location. Permits typically require an inspection by a local electrical inspector. The inspector will verify that the work meets the requirements of the National Electrical Code and local codes. The National Electrical Code, also known as NEC, is a widely adopted standard for electrical installations. It provides guidelines for safe electrical practices. The NEC is updated every 3 years to reflect new technologies and safety concerns. Some important aspects of the NEC include wiring methods, overcurrent protection, grounding, and bonding. Wiring methods specify the types of wiring allowed for different applications. Overcurrent protection includes circuit breakers and fuses, which protect the wiring from overloads and short circuits. Grounding and bonding ensure that the electrical system is properly grounded to prevent electrical shock. Local codes may also have additional requirements beyond the NEC. These codes may vary from city to city or county to county. It is important to be familiar with the local codes before starting any electrical work. Let's talk about specific examples to illustrate how these factors affect pricing. A simple residential receptacle replacement might cost $50 to $100, including the cost of the receptacle and the labor. A more complex job, such as wiring a new circuit for an appliance, might cost $200 to $500 or more, depending on the length of the run, a type of wiring, and the labor. A large commercial project, such as wiring a new office building, can cost tens of thousands of dollars or more, depending on the size and complexity of the building. When preparing an estimate for electrical work, it is important to consider all of the factors discussed above. This includes the cost of materials, the labor, the permits, and any other associated costs. It is also important to factor in a profit margin to ensure that the business is profitable. A typical profit margin for electrical contractors is 10 to 20%. The estimate should be clearly written and easy to understand. It should include a detailed breakdown of the costs and a timeline for the work. It is also important to be transparent with the customer about any potential changes or unexpected costs. When discussing flat rate pricing, remember that it can simplify the quoting process, but it may not always be the most accurate method. It is important to consider the specific circumstances of each job and to adjust the price accordingly. It is also important to communicate clearly with the customer about what is included in the flat rate and what is not. In conclusion, electrical installations involve a complex interplay of components, labor, and codes. Understanding these factors is essential for accurate pricing and safe electrical practices. Whether using a flat rate or a more detailed estimate, transparency and clear communication with the customer are key to a successful project. Remember to always consult with a qualified electrician for any electrical work to ensure safety and compliance with local codes. Now let's elaborate on some of the more technical aspects of electrical installations. Understanding these details can help ensure that electrical work is performed safely and efficiently, and it can provide a deeper appreciation for the factors that influence pricing. Firstly, wire sizing is crucial for safety and performance. The correct wire size depends on the amperage of the circuit and the length of the run. The NEC provides tables that specify the minimum wire size for different amperage ratings. Using undersized wire can cause overheating, voltage drop, and even fires. The most common wire sizes for residential wiring are 14 gauge, 12 gauge, and 10 gauge. 14 gauge wire is typically used for 15 amp circuits, 12 gauge wire is typically used for 20 amp circuits, and 10 gauge wire is typically used for 30 amp circuits. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. Secondly, conduit fill is another important consideration. Conduit fill refers to the amount of space that wires occupy inside a conduit. The NEC limits the maximum conduit fill to prevent overheating and to make it easier to pull wires. The maximum conduit fill depends on the type of conduit and the number of wires. Exceeding the maximum conduit fill can damage the wires and make it difficult to install or remove them. Thirdly, grounding and bonding are essential for safety. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker and prevents electrical shock. Bonding connects all of the metal parts of the electrical system together to create a low impedance path for fault current. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. Fourthly, overcurrent protection is critical for preventing fires. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a certain level. Circuit breakers can be reset while fuses must be replaced. The size of the circuit breaker or fuse must be matched to the amperage rating of the circuit. Using an oversized circuit breaker or fuse can allow too much current to flow, which can cause overheating and fires. Fifthly, voltage drop can affect the performance of electrical equipment. Voltage drop is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and electronic equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Voltage drop can be minimized by using larger wire sizes or by shortening the length of the run. Sixthly, arc fault circuit interrupters, also known as off-size, are designed to protect against arc faults, which are a common cause of electrical fires. Off-size detect the unique characteristics of arc faults and trip the circuit breaker to interrupt the flow of current. The NEC requires off-size in many areas of the home, such as bedrooms, living rooms, and dining rooms. Seventhly, ground fault circuit interrupters, also known as GFCIs, are designed to protect against ground faults, which can cause electrical shock. GFCIs detect the flow of current to ground and trip the circuit breaker to interrupt the flow of current. The NEC requires GFCIs in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor receptacles. Eighthly, surge protection is important for protecting electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors divert the excess voltage to ground, which protects the electronic equipment from damage. Surge protectors are available in different types, such as whole-house surge protectors and plug-in surge protectors. Ninthly, electrical boxes must be properly supported and secured. Electrical boxes must be mounted to a structural member, such as a stud or a joist. They must also be securely fastened to prevent them from moving or falling. Improperly supported electrical boxes can be a safety hazard and can make it difficult to install devices and fixtures. Tenthly, electrical work must be performed by qualified personnel. Electrical work can be dangerous and should only be performed by qualified electricians who are familiar with the NEC and local codes. Unqualified individuals can make mistakes that can lead to electrical shock, fires, or other hazards. Let's consider some specific scenarios where these technical aspects come into play. Imagine a homeowner wants to install a new hot tub. This requires a dedicated 240-volt circuit with a 50-amp breaker. The electrician must calculate the correct wire size based on the amperage and the distance from the panel to the hot tub. The electrician must also install a GFCI breaker to protect against electrical shock. The wiring must be run in conduit to protect it from physical damage and moisture. Or consider a commercial building that is being renovated. The electrical system must be upgraded to meet the increased power demands of the new tenant. The electrician must calculate the total electrical load of the building and install a new panel board with sufficient capacity. The electrician must also ensure that the wiring meets the requirements of the NEC and local codes. These examples illustrate the importance of understanding the technical aspects of electrical installations. By paying attention to these details, electricians can ensure that the work is done safely and efficiently. They can also provide customers with accurate estimates and reliable service. Remember that electrical work is not a do-it-yourself project. Always consult with a qualified electrician for any electrical work to ensure safety and compliance with local codes. The knowledge of these technical details not only ensures safety but also contributes to accurate pricing. Understanding the intricacies of wire sizing, conduit fill, grounding, and overcurrent protection allows for a more precise estimation of materials and labor. This leads to fair pricing that reflects the true cost of the project, benefiting both the electrician and the customer. Now let's examine the process of estimating electrical work in more detail. Estimating electrical work involves a combination of technical knowledge, practical experience, and attention to detail. The goal is to provide an accurate and competitive price that covers all costs and allows for a reasonable profit. Firstly, reviewing the plans and specifications is the initial step in the estimating process. The plans and specifications provide detailed information about the scope of the work, the materials required, and any special requirements. It is important to carefully review these documents to ensure that nothing is overlooked. Secondly, performing a site visit is essential to assess the existing conditions and to identify any potential challenges. The site visit allows the estimator to visualize the work and to take accurate measurements. It is also an opportunity to discuss the project with the customer and to answer any questions. Thirdly, creating a bill of materials involves listing all of the materials required for the project. This includes wiring, conduit, boxes, devices, fixtures, and panel boards. The bill of materials should include the quantity, size, and type of each item. The cost of the materials can be obtained from suppliers or online catalogs. Fourthly, estimating the labor involves determining the number of hours required to complete each task. This includes rough-in, trim-out, and final connections. The labor estimate should take into account the complexity of the work, the skill level of the electrician, and any potential delays. Fifthly, calculating the overhead involves adding up all of the indirect costs associated with running the business. This includes rent, utilities, insurance, and salaries. The overhead is typically expressed as a percentage of the direct costs. Sixthly, adding the profit margin ensures that the business is profitable. The profit margin is typically expressed as a percentage of the total costs. A typical profit margin for electrical contractors is 10 to 20%. Seventhly, preparing the estimate involves compiling all of the information into a written document. The estimate should include a detailed breakdown of the costs, a timeline for the work, and any other relevant information. The estimate should be clearly written and easy to understand. Eighthly, presenting the estimate involves meeting with the customer to discuss the estimate and to answer any questions. The estimator should be prepared to explain the basis for the estimate and to justify the costs. The estimator should also be willing to negotiate the price if necessary. Ninthly, following up with the customer is important to increase the chances of winning the project. The estimator should send a thank you note or email and should be available to answer any further questions. The estimator should also be prepared to revise the estimate if necessary. Tenthly, reviewing the actual costs after the project is complete is important to improve the estimating process. The actual cost should be compared to the estimated cost to identify any areas where the estimate was inaccurate. This information can be used to improve the accuracy of future estimates. Let's consider some specific examples of how these steps are applied in practice. Imagine an electrician is asked to estimate the cost of wiring a new house. The electrician would first review the plans and specifications to determine the number of outlets, switches, and fixtures required. The electrician would then perform a site visit to assess the existing conditions and to take accurate measurements. The electrician would then create a bill of materials listing all of the materials required for the project. The electrician would then estimate the labor required for rough-in, trim-out, and final connections. The electrician would then calculate the overhead and add the profit margin. The electrician would then prepare the estimate and present it to the customer. Or consider an electrician is asked to estimate the cost of upgrading the electrical system in an existing office building. The electrician would first review the plans and specifications to determine the scope of the work. The electrician would then perform a site visit to assess the existing conditions and to identify any potential challenges. The electrician would then create a bill of materials listing all of the materials required for the project. The electrician would then estimate the labor required for removing the old wiring, installing the new wiring, and making the final connections. The electrician would then calculate the overhead and add the profit margin. The electrician would then prepare the estimate and present it to the customer. These examples illustrate the importance of following a systematic approach to estimating electrical work. By paying attention to detail and by using accurate information, electricians can provide customers with fair and competitive prices. They can also ensure that they are able to complete the work profitably. Remember that estimating electrical work is a skill that improves with experience. By learning from each project and by constantly refining the estimating process, electricians can become more accurate and more efficient. The key to successful estimating is to be thorough, accurate, and transparent. By providing customers with clear and detailed estimates, electricians can build trust and increase their chances of winning projects. Now let's discuss the importance of communication with the customer throughout the estimating process. Communication is essential for building trust and for ensuring that the customer is satisfied with the work. Firstly, listening to the customer's needs is the first step in effective communication. The electrician should take the time to understand the customer's goals and to answer any questions. The electrician should also be willing to offer suggestions and to provide alternative solutions. Secondly, explaining the estimate clearly is important to ensure that the customer understands the costs. The electrician should break down the estimate into its component parts and should explain the basis for each cost. The electrician should also be willing to answer any questions about the estimate. Thirdly, keeping the customer informed throughout the project is essential for building trust. The electrician should provide regular updates on the progress of the work and should notify the customer of any potential delays or changes. The electrician should also be available to answer any questions or concerns. Fourthly, addressing any concerns promptly is important to ensure that the customer is satisfied. The electrician should be responsive to any complaints or concerns and should take steps to resolve them quickly and efficiently. The electrician should also be willing to make adjustments to the work if necessary. Fifthly, following up after the project is complete is a good way to ensure customer satisfaction. The electrician should contact the customer to ensure that they are happy with the work and to address any remaining concerns. The electrician should also ask for feedback on the estimating process and on the overall experience. These communication strategies can help electricians build strong relationships with their customers and can lead to repeat business. Effective communication is not only important for customer satisfaction, but it is also essential for avoiding disputes and for resolving any issues that may arise. By being transparent and by keeping the customer informed, electricians can minimize the risk of misunderstandings and can ensure that the project is completed successfully. Remember that customer service is just as important as technical skill. By providing excellent customer service, electricians can differentiate themselves from their competitors and can build a strong reputation in the community. In conclusion, estimating electrical work is a complex process that requires technical knowledge, practical experience, and excellent communication skills. By following a systematic approach to estimating, by paying attention to detail, and by communicating effectively with the customer, electricians can provide fair and competitive prices and can build long-term relationships with their customers.